Yeah, we'll go ahead and get started in the essence of time. We have a lot to cover today. My name is Peter West, sometimes known as Professor P or Professor Peplink, and with me is Travis Durick from Peplink. And we have a special guest, and I hope I say your last name right, Jason. Jason Snellbacher, is that
Yes,
right?
sir. Yep. Jason
Yes, and I
Schnellbacher.
got
I'm in
Jason
the,
Snellbacher from T-Mobile, if I'm allowed to say that. And
yes.
uh, awesome. And I'm really excited because today we're going to talk about 5G, 5G standalone, and network slicing and what these technologies are. And then we're going to go a little bit of why they matter in bonding and how Peplink basically uses these technologies to enhance your network and deliver increased reliability and performance. And so it's going to be a really neat conversation today. And I'm super excited. That's this slide right here. So Jason Snellbacher, do you want to introduce yourself a little bit?
Yeah, hi guys. Jason Schnellbacher. I'm in the Technology Innovation Department at T-Mobile. 26 year sprint now. T-Mobile worked on 3G, 4G, and now 5G. Been working on 5G since 2018. And working on network slicing projects and in the real world commercial network deployment since 2023. So I think I did over a dozen slicing projects last year, and happy to talk with you guys a little bit more about the technology. I'm in the technology organization, so I'm going to talk about technology. I can't really talk about kind of commercialization, productization plans, but I can explain the technology and how it's used and why it's relevant.
And Jason, I mean, you and I have worked on some pretty cool projects together with Peplink and network slicing for the past, like, what, 2 years now? Three
Yes.
years? Yeah. So pretty fun. And Peplink and T-Mobile have worked together to try to make sure that the technologies work well, kind of together.
I just want to point this out because you just said you did how many 17 slicing deployments last year, Jason?
Yeah, I stopped counting at around 12 or more. Yeah, so it was
But
over one per month on average.
what I want to point out here is like what we're talking about is technology that's not yet really commercially available to pretty much anybody out there in the market. And so this has already been going on for 2 years in the background. And so it's pretty cool to see how much work and front end effort's been gone into this and, on the T-Mobile side and the Peplink side. But yeah, you guys are blazing trails that nobody else has really had a chance to get onto yet. And so this is exciting to kind of get this technology preview right now.
What's neat to me is working with T-Mobile over the last couple of years, how much effort and work actually goes into proving these technologies. I mean, as a consumer, and I know we're not going to talk about productization, but as a consumer, we're just taking advantage of the fact that these networks and these technologies are available to us. And you got people like Jason and the T-Mobile team that are out there every single day making sure that it actually delivers and works the way it's supposed to. And it's really cool to watch and be part of. So anyways, Jason, thank you so much for joining us.
You're welcome.
So first I want to talk about 5G standalone, because this is really the basis of what we need to be able to do other advanced features. And so what I'd like to do, Jason, is just from a technical standpoint, and why does it matter? What is 5G SA? And I don't know if you're allowed to tell me this, but why is only T-Mobile have this right now? Why is it, like, what makes it difficult to deploy? Or, you know, what's, I don't know. I don't know how to say that question. I want to stay within the bounds of what we're allowed to talk about, but um, you know, I think it's interesting that you guys have four, if you count 41 has two sections there, but I mean, you have a lot of SA available network. And so why is T-Mobile investing so heavily in that?
Sure. Well, standalone is the future of 5G, right? And so, quick history lesson is probably helpful to understand standalone. So, the cellular industry has standards, industry standards defined by 3GPP, right? And I don't know, they should maybe call it 5GPP now. Partnership project, I think, is what PP stands for originally. But anyway, it comes out in releases. So the first release of 5G was release 15. Okay, and that first version used 5G new radio NR. Okay, that's what, if you ever see 5G NR, that's what it means, new radio on the radio side of the network. But the 4G side was still used for the core. And the reason they did that was to bring it to market faster. There's a lot of complexity that goes into the core part of the network. Okay. And then what standalone 5G is that you're really using 5G on the radio, on the RAN, the radio access network, as well as in the core. And when you have it in the core, and that's the part that's unique. And for T-Mobile, we invested in that early because we have we actually have the extended range coverage. Okay, so the 600 megahertz, which is the lowest frequency band in the United States, it travels the furthest distances. We've tested some really amazing distances with that kind of technology. But to get the benefits of that, you really have to be SA. Because if you run it in NSA mode, you're limited to the mid-band anchor band, right? So you run what's called the anchor band. Your 4G would be like 1900 or AWS, which is 2100. And so you can only go as far as those bands. But if you go SA, you don't need those 4G bands anymore. And you can go all the way to the extended range. And that extended our coverage radius like significantly. And that was the big reason, the big push early on. It was in 2020. T-Mobile was first deploying the standalone core, and now it's been deployed, and it enables us to do a lot of new advanced features and things. But that's kind of really what it is it's a 5G in the core with a user plane function, which is where the traffic terminates and effectively goes to the internet, and that's all possible with 5G core.
I do want to add that I have a Peplink antenna. Oh no, you can't see it. There you go. And this antenna, I don't know if I can get it so you can see it, but it says 0.6 to 6. And so when you're talking about 5G SA, and I get people complain, every antenna is not the same. You have to have an antenna that can support the frequency range to connect to these 5G networks more appropriately. So you can't just say, oh, it has the right SMA connector. It needs to be able to support the frequencies that are being offered by the carriers as well. Just because you said the 600, what band is 600? What actual is that? Is that 41?
No, that's 71. So
Oh, that's
600
your okay.
megahertz is the N71. So that's
So
the
in 70,
extended range, right? Like, I mean, multiple miles. Like, I think there was a
yeah.
test where we went like 50 miles at one point. But that was just a, kind of a showcase example. But like my point is very, very wide coverage. It also goes in buildings and basements a lot better, right? But that's called the N71 band.
Excellent. And so how does 5G standalone provide lower latencies? Because if you're just authenticating, wouldn't NSA and SA provide the same latency?
They can be similar, but the SA is better. And usually we see on average around 10 milliseconds better with the SA versus NSA or LTE. A lot of that comes from you having a new upgraded core. So instead of kind of a legacy core, you have the newer one. Each generation it gets a little more efficient. So there's some efficiencies there, but also the widely distributed. I mean, we have I think like over 5,000 UPS distributed across the country in 40 or 50 different data centers. I can't remember exactly the numbers, so don't quote me on that. But the point is it's very widely distributed, right? And because they run on virtual machines, and we're able to spin those up as needed and load balance those across the country, make them geographically redundant and all that good stuff. But the fact that they're closer to the users is what helps make that latency lower.
So it's not so core like it used to be, right? It's spread out more, much
Yeah,
like
for example, we had at Sprint back in the day, I think we had 12 regions at one point, right?
okay.
And all the traffic would go to 12 places.
Mhm.
Now it's like somewhere between 40 and 50 different
Wow.
data
And that's
centers.
the 5G core.
Yes.
Wow. Okay.
That's
And
awesome.
and you had mentioned something too, um, and once again, just say no if that's the case. But you require a minimum amount of bandwidth to your towers that are 5G enabled, right?
Oh yeah, yeah. We can't really run. You don't want to have a backhaul, is what we call that, right? That's the connection into the tower that is really a private line that goes to those data centers I was just talking about. You can't really, with all the radio capacity that we have, you don't ever want your backhaul to be smaller than your radio capacity. right? And the only time you really allow that to happen is if it's emergency response and you're running on a satellite and there is no other service, right? But otherwise, like 1 gig is a gigabit per second is really the lowest end, and we don't even really prefer to run that kind of connection. We would generally would, and I think most carriers would be the same. We want 10 gig fiber into every tower.
That's crazy. I mean, that's crazy numbers to me. Like, think about the number of towers and having 10 gigs to these towers. And then having that all trunked to some massive data center. You probably have like 400 gig pipes or something coming into those data centers.
Yeah, I mean
Um,
that's what it takes when you want to be the leader in 5G.
yeah, that's nuts. And I'm assuming that then contributes to our next point, which is higher capacity, right? I mean, if we have more backhaul, we have more backhaul capacity, and then we have newer radios and more powerful cores. That's what allows you to have more clients, is my
Yeah,
guess
and
on
you
that.
can have higher spectral efficiency. So when you're in the really good RF conditions, you can get higher peak speeds when you're running on 5G, new radio, and then the number of connected devices is really important, particularly at large crowd events. So there's a number of connected simultaneous users per sector, and there can be limits on that, right? And so 5G increases the limits. And I know probably everybody's been to a large crowd event and not had their phone work in years past, but that's becoming less and less of a thing. I've been to many events and the phone worked great, but it wasn't very long ago it didn't, and that's another good
Yeah.
example where 5GSA can make a difference.
I mean, I've been at events with you where like we're at NAB, for example, and we were getting like 1.3 gigs on that, at the convention center. Now, I'm assuming that's millimeter wave, but still really fast capacity. And, even during the event, I think it only dropped to like 700 or 800 megs versus 1.3 when we were, when the venue was empty. Whereas in the past, I was lucky if I get, 3 or 4 megabits per modem.
That's right. Yeah, yeah, that was the
So
millimeter wave or high band
yeah,
5G.
yeah,
So we kind of
yeah. We
think
were using
about
the
the layer
Samsung.
cake example, right? Where you have the low band is the wider, thinner piece, right? And then you have the mid band, which has got a great mix of both coverage and capacity. And then the ultra high band or the high band or the ultra high capacity part is great for public venues.
Now, question about that. Are there theoretical maximums that you would have at each of those bands? So not saying like a T-Mobile or any other carrier, but are there like that 600 megahertz, that low frequency 5G, is there a theoretical max that you would have on that with 600 megahertz? Or
Oh yeah. Oh yeah. In the cellular world, there's a lot of math majors, engineering majors that can calculate those theoretical maximums. And yeah, so it's based on the size of the channel, and the number of users and what kind of RF conditions you're in. So if you're a single user, right, and you're in the
yeah.
most ideal RF conditions, then you would expect there is an expected maximum number that it can be achieved. Yes. And so, but
And
then what happens is it's kind of a complex math, right? Because people ask me all the time, well, how do I, assume how can I, estimate what the capacity is going to be? Can I support this many cameras or whatever? And I'm like, well, it kind of depends on, what kind of RF conditions that they're in, how many other cameras there or other devices there are. And so it's a little bit of a complicated model to estimate that. It's not linear. In other words, it's very much has multiple variables.
yeah, that makes sense. But I mean, but I would assume 600 is less maximum than mid, which would be less than ultra high capacity, which is less than millimeter wave.
Yeah, 100%. Yeah, yeah, you got it.
Okay.
Yeah.
Um, I got a really cool question on from somebody. It says, does T-Mobile support local breakout on 5G SA? And I actually don't even.
Yeah, so this is one where I kind of chuckled is this is one that we've been working on in the technology innovation department, but we have not made any announcements. Stay tuned.
Okay.
Maybe in a couple weeks you might hear more about this topic from T-Mobile.
Could you tell me what local breakout is?
Yeah, local breakout is a 3GPP industry defined term, where we put the core part of the network at the customer premise or at a venue, so it can effectively enable local area network routing. So
And
another key thing that is beneficial for standalone 5G, right? But if you want to have a manufacturing plant and run AGV, automated ground vehicles, and have ultra low latency machines and stuff like this, then you need that traffic local. For video production is another good example. You need that traffic local to hit the lowest latency, and so that's where edge can the local breakout in edge processing can make a big difference.
okay, yeah, that makes and that's similar to some stuff that we've done together then.
In a private network. So it's kind of like giving you in a private network, you generally have the core on site, so you can do local area
Yeah,
network routing. In a public macro cellular network environment, all the traffic goes through a tunnel to one of these other data
yeah.
centers I talked
So
about,
this
right?
is local breakout on a public network.
Yes.
Oh wow. Okay, that'd be really cool.
But yeah, I'm just talking about the
Mhm.
technology today. But yeah,
Correct.
that
Yeah,
it's
not commercialization or productization.
but yeah, no, it's an exciting thing to look forward to.
That is neat. Um, I'd love to. I know how I would answer this. I'd love to know how you would answer this, Jason. What are the benefits of 5G for real-time applications like autonomous systems, and why not use Starlink? And you don't have to speak to Starlink if you don't want to, but I mean, I know how I would answer this, but I'm curious how you would answer this.
Yeah, so with 5G, we can keep a consistent bidirectional link that is both low latency generally. We're lower latency than Starlink when we're in decent RF conditions or good RF conditions, and so we have some advantages there. We don't have to go as far, right? We don't have to go to space and back. But I mean, credit to the Starlink team. I mean, they've actually really made that latency pretty darn good with low Earth orbit constellations that they have, and so it's pretty good. We've used Starlink actually bonded with 5G with Peplink products before, and when I look at the traffic charts every time, they look pretty spiky. Where there's some peaks, but there's also some valleys, and it's not quite as smooth. And if you're trying to stream video, particularly higher bit rate video, your throughputs can drop below those levels sometimes, and so that makes it kind of challenging. And where the 5G is a little bit more consistent, I would say, and it does have some benefits for that kind of autonomous use.
And I would say this very similar and same is what I've noticed with 5G, especially 5G SA, is more predictable throughput reliability versus those spikes. And we have graphs and charts to show this. Is that like a T-Mobile? It's funny. T-Mobile, if I'm pushing 20 megs, it's either 20 megs or it'll be none. And then something else. It doesn't. It's not doing this. It's doing this as I drive around an area. As I move around, it varies. It does vary, but it's a lot more stable during those variances.
Yeah,
Whereas Starlink provides us low latency and then can fill in the gaps. And we did a project together where we actually used Starlink to fill in some gaps. So it does work. It's not Starlink doesn't work. It's that what I've seen with 5GSA is that more predictable, lower latency. And I don't know how to technically speak to this. I might have to ask someone in Starlink, but I do notice that with 5GSA, we have much less packet loss than we do with Starlink. And Starlink, I'll usually see anywhere between 13 and 150 or so packets per second of loss, which will affect autonomous vehicles significantly. And so we have to do WAN smoothing or forward error correction a lot more aggressively than I do with standalone networks.
great point.
And
Yeah.
and not speaking against Starlink at all. I love Starlink. We use it for a lot of projects. It's simply to answer that direct question of why would you do 5G over Starlink or in lieu of it, there's a couple technical benefits. And I think it is because it's not traveling as far. I mean, right? We're going to a tower and then going to fiber versus going to space and bouncing between lasers or other Starlinks and then, hitting a ground station, then hitting fiber. So there's just more
Yeah, keep in
hops
mind
in the
there. I think
path.
they're going. I can't quote it exactly, but that's like 10,000 miles an hour. Like those satellites, they're super
Tw-
fast.
12,000 miles an hour is what I
Okay,
heard.
okay,
So
so they're going
yeah,
super fast. So as they go to the edge, I think that's on this side and this side. That's kind of where you probably see some more of the packet
yeah,
loss, if I had to guess.
Yeah, I think for autonomous systems, the line of sight thing is the biggest hurdle for Starlink. It's a great complement, but if you've got a system that's moving around, any visual obstruction is going to, break that feed in an autonomous system. That's going to be a huge challenge. So outside of boats, I think 5G is going to be the go-to choice in most cases, is the primary at
So
least.
So now that we've talked about low latency capacity and reliability, let's talk about some of the advanced features that SA brings to the network, such as network slicing, which I don't want to go too deep right here, but it does, we need SA for slicing. Is that correct?
That's right. Yeah. So
Okay.
SA is the enabler for network slicing.
And then you mentioned, and it doesn't enable 5G, private 5G. We can do private 5G on NSA and CBRS, but it improves 5G, private 5G networks
Yeah,
because
for
we get
us,
that.
for many of the same reasons that SA is better in the macro network. It's those also apply to a private network. Um,
And then during our meeting or prep here, you talked about advanced features and you talked about versions of SA. And I would love it if you could just touch that a little bit. You talked about 15, 16, 17 and carrier ag. And I would love to actually for my own learning as well. I would love to understand that a little bit more.
Yeah, sure. So, like I mentioned, the 5G is, associated with releases, industry standard releases. The first version of 5G was release 15. The second generation is release 16. And a lot of the current Peplink products, for example, are in that release 16 family, right? And so they're native with standalone 5G capabilities. But then the next version that's really out on phones and soon to be out on embedded modems and embedded products is release 17. And release 17 is probably notable for this audience because it brings uplink carrier aggregation. We've had downlink carrier aggregation for many years, and I've commonly received questions around why is the downlink so much better than the uplink? And there's two reasons for that. One is that because 80% of the consumption of the customers is downlink, there's more capacity allocated to the downlink when we use TDD spectrum, time division duplexing spectrum for our mid-band 5G, our N41 ultra capacity network. 80% of that is tuned to the downlink, right? And 20% is allocated for the uplink. So it's kind of an 80-20 kind of setup. And so that's part of it. But the other part is that you've been experiencing carrier aggregation where there's multiple carriers in the downlink direction. But not very many people complain to me and say, oh, I need more downlink. What I hear much more commonly is, how do I get more uplink? And many of you'll be happy to hear is that the industry's been working on this. T-Mobile's been working on this a lot over the last few years. A lot of our tech roadmaps focused on uplink recently, and with release 17, it brings uplink carrier aggregation. And so that's the ability to transmit not only on two antennas per band, uplink transmit MIMO, but also uplink carrier aggregation to transmit on frequency 1 and frequency 2 in the uplink direction at the same time. And that's new. And that's the key part of release 17.
That's cool. I
And
mean,
is
that's
that
been happening on the downlink for a long time, right? You've been using one or more frequencies to get more and more speed, but the uplink has not had that yet on 5G.
Exactly.
and is that correlate to like the chipsets like X55, X65, X75? Or is
Yeah,
that
it does.
is
No,
that
you're right. You're right on. So like the first generation is the X55 chipsets, right? That's the release 15. These are embedded modules I'm referring to here, the type that would be in routers, not phones. They're a little different type that go in phones. But yeah, X55 would be release 15, X62 and X65 would be release 16, and then release 17 would be X72 and X75. So
okay?
those would be the newest generation. So when you see products that have those, they're generally going to support uplink carrier aggregation as long as the network supports it, which T-Mobile does and has for some time.
That's awesome.
Yeah, there's
So
always a new generation of modems, and those are things that Peplink's working on as well. So like, you just mentioned these different generations, the X62 and X65, those are our currently shipping 5GN and 5GK SKUs. And then
yep.
the X72, we've already got test units out there. We've got samples out there to test these features like the uplink carrier aggregation and those things. So those I don't have an ETA yet, but they're in the engineering roadmap. They're happening, and so we're trying to move just as fast as you guys are on deploying these new releases, new technologies.
I appreciate that. You can only get the best out of the network when you have the newest, latest, greatest devices. So we appreciate that.
So I'd love to move on to network slicing. And it wasn't until you and I had a little talk and you drew me a picture of, you're like, draw a cylinder. And that I really, I mean, understood the benefits or value of slicing. And I think it'd be really important to share this with the audience. And once again, we cannot answer questions about productization or commercialization. This is a technology, so we just simply won't address those questions. But network slicing, as it relates to 5G SA and enhances, my understanding is we're basically literally a slice. We're taking a piece of spectrum and we're dedicating or it's almost like a QoS, right? We're taking a piece of spectrum and allocating it to a need. Talk about slicing for me and how that helps.
Yeah, so dedicating spectrum is not something that is generally looked upon favorably for mobile network operators, right? That's the scarce resource that really drives the business, and so we don't really, and I speak broadly for carriers, probably globally, right? Is don't really like the idea of dedicating frequencies or spectrum, because if it doesn't get used, then it's like, it's not very efficient, right? And so what's much better is to actually do logical partitioning. So think about network slicing. You got a lot of networking people here. I'm sure everybody knows about a VLAN, okay?
Mm-hmm.
And probably know about VLAN tagging. Or maybe DSCP, quality of service tagging, okay, where you tag the packets, and once they're tagged, in this case, they get a slice ID. Okay, and once they receive that slice ID, they can be treated uniquely. And really, what that gives the mobile network operator is the capability to customize how the network is configured for that particular type of traffic. And it's not just priority. A lot of times, people think about the network slicing as being priority, and it can be, but it doesn't have to be. It can be other things. There are multiple types of configurations that can be customized, to be able to support specific use cases. So think about a slice as we look at a specific use case, and then we customize the network for that use case. And I'll give you a good example. A public example is T priority. This is a service for first responders, police and fire, ambulance, and they need to be able to have priority in times of an emergency, right? And so they need to have some minimum types of bit rate guarantees, and so we're able to do that with network slicing. Okay, so we can give that one 5x relative priority, for example. Okay, so it has a much higher priority than others. But we can also use the same kind of approach, right? It's a construct, it's a framework that allows us to customize it. We can do things specially for robots or drones. We can do things for video broadcasting. We can do things for point of sale or IoT. Whatever it is, you can customize the network. So that's really what network slicing is it's tagging traffic, allowing the network to then provide custom configurations for that type of traffic.
Because the T priority is actually a public service. So I thought T priority was just and I might butcher this term, but a QCI.
QCI is a 4G term, and
Okay.
it's
Okay.
QoS class identifier. Okay,
Okay.
and yeah, you have different QCI values, and like there's one for VoLTE and voice, for example. Okay, and then you have maybe kind of some user groups might be in different categories, and that's kind of how segmentation in a very broad way was implemented in 4G. Okay.
Okay.
In 5G, QCI is replaced by a term called 5QI. And it's a very similar concept. And the network slice will map to a 5QI value on the back end of the network.
Okay, and that's how you're able to give first responders that guaranteed quality, not guaranteed, but that higher quality of service.
Yes.
Okay, awesome.
Yeah, basically think about it like this. The network knows, oh, look, this is a first responder customer. I need to give them this higher level of service.
How does slicing provide extra security?
Can provide extra security for things like SASE, and basically instead of tunneling traffic to a core network that's shared by everybody else and then going out to the internet, some customers want really secure environments, like they have, you know, corporate trade secrets, and they have a lot of other sensitive things that they just flat out don't want to go to the internet. And so network slicing can have routing capabilities associated with them as well that can route to a SASE gateway and deliver the traffic privately to an enterprise customer, for example, so it can never go to the internet and always have stateful network-based security along on top of it.
How are slice IDs like VLANs? Like you mentioned that earlier, but like I know you said like there's a slice ID. Like how does uh
Yeah, think of it
a
very similar.
router
It's just
or yeah,
concept wise, right? It's not, you
yeah,
know, exactly the same. But if you understand VLANs, then you'll understand slicing, right? Like so, you may want to have a VLAN. Let's I do a lot of events. Okay, so you may have a VLAN for ticketing. So all the ticket scanners go on one SSID for Wi-Fi, which goes on one VLAN in the LAN, right?
yep.
And then you might have a different one for the point of sale registers, right? And so that has a different SSID, which maps to a different VLAN, right? And they're different types of traffic, and you want to handle them differently. Some cases you want to route them differently. Sometimes you want to maybe give them a different quality level of
Yeah.
service. And so
And on the
network slicing is the same concept applied to 5G cellular networks.
LAN, we used to do, well, not used to, we do, we'll do like DSCP tagging and COS, quality on the switches to prioritize, Teams meetings, for example, over someone's YouTube traffic.
Yeah,
And
that's
so,
application based, and which
yeah,
is also an interesting topic that's probably worthwhile just to be thorough for your audience. Is that within network slicing, there's a few different approaches. If you can't tell, the cellular industry likes options. Not everybody, likes the same things and wants to do it the same way, and so the industry standards are usually written where there's options. Okay, commonly there's options. And so you can have a full device slice, meaning the slice is associated with a SIM. So all traffic on the SIM gets the slice tag. Okay. And that's the easy way to do it. And that's the way most things have been implemented. Really in the early days of slicing. Then the next frontier that is still emerging and kind of still in R&D type environments is application-based slicing, right? Where you may have a single modem or WAN connection, and some traffic is on a slice, and some traffic's not on a slice. Okay, and that requires some new special technology in the 3GPP world. That's called URSP, for example. And we have at T-Mobile and other carriers also have APIs to be able to do this kind of application-based slicing. But that's important to understand the difference between kind of an always-on slice, which is all traffic, which is really good for purpose built devices and use cases. If they only really do one thing, you can just prioritize the whole device, everything's fine. But if you have a multi-function device and some things are important or more important than other things, then that's kind of a scenario where application-based slicing is an important concept.
someone asked a question, how do specific slices differentiate from the more standard nationwide slice? And will the nationwide slice always have priority over a customer specific slice? So it sounds like if you had competing slices in an area,
We
how would
don't
that happen?
though. I think that just needs to clarify the understanding of that. Is
Okay.
that for the mobile network operator, the slice is defined per use case. Okay, there might be multiple slices offered by or enabled by a mobile network operator, and those are generally deployed nationwide. right? At least in the case of T-Mobile, where we would
Yeah,
have a
IT
nationwide
priority.
SA project, in a network, for example. It's not like we have SA in some places and not in other places. It's nationwide. And so that slice is then deployed and it's available everywhere. So it's not just one type of nationwide slice, right? It's a slice by use case, and those use cases and those slices are once they're kind of decided upon by the engineering team, are deployed on a nationwide basis. Now you can customize it for specific events and things like that, but nobody likes doing that because that's manual and labor intensive, right? And so it's much better and more scalable to define these and then roll them out on a nationwide basis.
We talked about public safety a little bit. Do you mind talking about how slicing can help with point of sale and transit,
Yeah,
even
sure.
if it's on a
So,
theoretical?
yeah. So this is, just kind of a concept and a use case reference here, right? But accepting credit cards and getting real-time authorization seems to be important to retailers. And generally there's not a problem with that until you want to try to do that at a large crowd public event. And sometimes that doesn't work so well. Or even maybe you're in a high traffic retail area at Black Friday. Okay. You need to, you really kind of would like to have some type of capacity protections, congestion protection mechanisms in place to be able to ensure that those credit card authorizations come back. Yeah, this card is good. You can go ahead and release the goods. You're going to get paid. Because what happens sometimes at events where retailers can't get real-time authorizations, and the network is basically unavailable, then they end up having to either shut down or they give merchandise, food, beverage, or whatever it is, out without any confirmation of payment. So they're gonna like store and forward, right? And nobody likes that either because some percentage of the cards are gonna come back as declined when they actually run those later after the event. And so this allows for real-time authorizations even when there's crowds. And that's kind of what that's about.
That makes sense. I'm Professor Peplink, and we like to talk about how these technologies apply to Peplink. And it's so funny when Starlink was first announced, they go, "So are you worried that Peplink will become irrelevant?" And it's funny because as these new technologies emerge, I always go back to one of Travis's first statements, and it's just all we're doing is increasing the level of nines. Like the more different connections we have and the capability we have, the the better opportunity for reliability or bandwidth or consumption. But we talked about carrier, upload carrier aggregation, and we've done some really neat projects around bonded SA networks, like actually combining like N25 and N41, or even N41 and N41 with where you have more than 100 megahertz of frequency available. Would you mind from a once again a technology standpoint, what you've seen with Peplink and the ability for it to handle multiple 5G SAs at the same time?
Yeah, that's one of the things we love best about Peplink, right? Is the multiple modems and being able to bond them together. So, in the last few years, we haven't really, at least in terms of embedded modems and routers, haven't had a link carrier aggregation. And so to get the most of what our network can support, you mentioned earlier, we have 3, 4 different channels of 5G SA on most towers. Right. And in order to kind of get the most of all of that, right? Like in the uplink direction, you need multiple modems, and you can do band locking to put modem 1 on frequency 1 and modem 2 on frequency 2, and then bond those together. And it's been really great. I think that sometimes people might say, okay, well, when you have uplink carrier aggregation, maybe you might need bonding less. And I said, well, I don't know. A lot of the reasons for using bonding is more than just higher uplink, although that is a very big driver. It's also higher reliability. It's diversity. If something were to happen with one connection, you still have another connection. So I still feel like it's very relevant for those types of enterprises that need mission critical connectivity, even when you have uplink carrier aggregation to use bonding. But yeah, you can bond. One example, we did a project where we had 5G SA on frequency 1, 5G, which is in this case was in 41, 5G frequency 2 was in 25 or 1900 megahertz, and then we had 2 Starlinks as well, and we bonded all of them together with WAN smoothing in a very challenging conditions, and and it worked great. Right, and so being able to put all of those together is a big advantage of using the Peplink.
I was just going to say, I think one thing that is important to keep in mind here for users is, these slicing technologies are awesome, right? They're adding a lot of capabilities and protection and more consistency, but you're still talking about a finite resource, right? It's not unlimited, right? There will be limits to how much you can slice and protect things, right? If everything is sliced and highest priority, nothing is, right? And so ultimately, there's still limits to this technology, and those are times when you will need multiple networks, multiple connections, and you will use speed fusion and things to go beyond that. But this is a huge step, even still for those applications.
I had someone ask, and I know the answer to this, but I thought I'd ask anyways. For private 5G SA, is the radio network shared or dedicated private?
Well, it can be either one. Again, remember, there's options in the industry. I would say that the best practice would be to use a channel that's not used by the surrounding macro network, right? So in other words, a clean channel is really ideal. You're going to have a bigger coverage area, better SINR, signal to noise ratio. It's going to work better. You're going to have more dedicated capacity. So having a dedicated licensed frequency for private network is really the best. Then you could have dedicated semi-license with CBRS or other things that maybe isn't quite as good. There's risk associated with that. You can sometimes get quite a bit less. I don't know if people really understand the difference between license and CBRS, but there are quite a few differences in terms of output power, in particular, and the types of capacity that can be supported. But the best practice is to have a separate clean channel that's not used by the surrounding macro network, and that for lots of reasons, but including capacity and radio planning.
Another good question someone asked is slicing end to end through the network? I would assume yes, if it's a nationwide.
Yeah, it kind of. This is another one where I'm going to be kind of specific in my response. Okay, is the standards are written in a way that allow for full end-to-end, meaning in the radio and in the core. Okay, but a lot of operators are doing an implementation in a phased approach, where the most important part of the network slicing is on the radio network, because that's the more constrained, scarce resource. And in the backhaul and transport network, those are typically over-engineered quite a bit, where the maximum, utilization thresholds are set around 40%, right? Because if there was failover, you still be at 80, and you still need headroom and time to go and add more capacity. So the need for a slice inside the core network is quite a bit less, but the standards are written in a way that can be used in both the RAN and the core. But operators are generally implementing that in a phased approach, starting with the RAN, which is the most important part, because that's generally the bottleneck.
Yeah, that makes sense. The and to speak to some of that, and once again, kind of like how that implementation works with Peplink, is with our bandwidth with speed fusion bonding, we're able to aggregate multiple modems together like we did with that one project. So you can have like N41, N25, even Starlink and other connections, and create that increased throughput if it's available, because we can combine 21 and 41, or 25 and 41, but also increase stability as those networks vary a little bit. Even those little tiny variances or the spikes that we see sometimes with some of the other technologies, we're able to then basically accomplish the desired capacity that we're looking for. So if the mission is to send a 40 megabit per second video stream, by being able to combine N25 and N41A and N41B, we're able to make sure that no matter what's happening on the user plane of that network, especially with the slices set aside as well, we can then bond all that together to make sure it's nice and clean and smooth, and we get the upload capacity we're trying to achieve.
Yeah, and as a real user, like, I mean, I'm here to tell you, like, that works. It works well. It's effective. The dynamic balancing of being able to shift the traffic is really good. I love the charts. I love seeing the charts in real time to see how it's handling that traffic. And we've done some really sophisticated things about thresholds and cutoffs and how to even kind of keep that in a tighter range that have really improved the outcomes of some of our projects. And so that's good. But you hit one thing too. I want to emphasize a little bit more that is maybe not well understood. You mentioned N41 channel 1 and N41 channel 2, and we talked earlier about carrier uplink carrier aggregation. Like a lot of things in cellular, there's going to be a phased implementation. Well, the first phase of uplink carrier aggregation is T plus F, or F plus T, which is basically TDD band plus an FDD band. Okay, so N41 would be a TDD band, N25 would be an FDD band. Okay, and so you can uplink carrier aggregate those two bands, for example. Okay, might be a little different with other carriers, but you get the concept, right? TDD band, usually mid-band frequency, in an FDD band. And the uplink carrier aggregation for T plus T, which is two TDD bands, doesn't come until later. It's another another future release or phase. And so with the Peplink product, it is possible to set with special engineering commands, the modem 1 to use N41 channel 1 and the second modem to use N41 channel 2. And so this is a pretty sophisticated thing. You kind of need to work with a carrier to do this kind of thing, but it's very effective, and we've had good results doing that. And that's something that, like, the need for bonding, still persists even when uplink carrier aggregation starts to become more available.
Jason, I know you're not talking about specific go-to-market or commercialization efforts, but it seems like a lot of the things that you're talking about and doing in the field is part of that process of, like, seeing how this works so that it does inform that productization and commercialization process. So they know how to take that thing that you're doing in a very manual engineering focused way, but translate that into something that is, achievable and simple and purchasable for customers. And seems like that's moving along well, but is that kind of what's going on in the background when you guys are doing these things?
Yeah, 100%. Well said, right? We got to, like, validate this stuff works. Like, you can't, like, make a product if you're not confident that it's going to work, right? And so, for us, that means, like, go take it to a gigantic event and see how it works, right? Put it in some of the most challenging conditions that you can imagine, and that's a lot of what we do within the technology innovation and department, right? Is we, we're always scouting out new things, trying to, we want to then try them out in the real world. We want to validate that they work, and then share that with, in this case, T-Mobile for Business, to be able to take those insights and be able to use that to turn it into products that are scalable. But there's a lot to go into it, right? Sometimes I think that some of what we do is maybe even a little bit easier on the tech side, right? Like, we get to turn it on in the network, okay? But the idea of, well, when and how can you make it available, right? Is that something that's generally available everywhere, or is it only available in some places? So you have an eligibility concept, okay? But then you need to order it. How do you order it? How do you bill for it? How do you support it? If there's a problem, you need to be able to do troubleshooting and tickets and train people. And there's a whole lot of tools. There's a whole lot of stuff that reporting that has to happen in order to make it a product. So they're yeah, maybe not well appreciated, right? But there's a lot of thought that goes into that, and that's really the next step after validation. You got it.
Mhm. Cool.
Somebody asked, and I actually don't know what this is, so hopefully you do, but it says, when will SA be available for P5G deployments?
We're already doing that. So P5G in this case is private 5G. right? So the question
So
is,
I'm sorry. My bad. I
yeah,
saw
you're,
P5G and you've said so many acronyms, and then I was like, my brain just broke apparently. Yeah, we're doing SA now for private 5G.
yeah, we've been doing
So
that for a while. In fact, this is public, so I can share this. Is that we recently were the first, I think, in the U.S. to run what's called NRDC, which is new radio dual configuration. It's basically a way of supporting millimeter wave high band 5G with mid band 5G SA as the anchor band. Remember how earlier I was talking about millimeter wave
yeah.
has to run 4G as the anchor band? Okay, and that causes other challenges with how you move between the modes. Okay, in this example, not only is private 5G available with standalone, but it's also available with NRDC, where there's millimeter wave, high band, and mid band both, and that's enabled with 5G SA on the private network.
Oh wow, that's really cool. Um, Travis, do you want to speak to this?
Yeah, this is an event that we are sponsoring, being showcased at the T-Mobile for Business Response Readiness Summit. I don't know if this is just for T-Mobile sellers, honestly. I know we're gonna have folks there live representing it, but yeah, this is coming up quick here. But yeah, it's a public safety focused event.
So
Okay,
it's going to be
so
all
really, like a
about T priority for police and fire. So like this is like putting a BR1 or BR2 that are made for vehicles, right? They're ruggedized for high heat, dust, vibration. You can be mounted in a truck and in the middle of summer in Arizona, and it still works, right?
Yep.
But what one of the things that the T-Mobile is going to want to feature here is how that T priority service can really benefit the police, right? And so
Yep.
if they had two modems, for example, they could put one on T priority and one on FirstNet, for
Mhm.
example, right? And you can do some really unique things that really make a difference for the safety of the public.
Yeah, and we've got a really broad base support for the T priority feature right now with our lineup, and so that's really what we're gonna showcase there. But yeah, if you're
Right,
in
because you
Chicago,
actually have there's a T priority certification at
yeah,
T-Mobile, right?
yep,
Which is like a specific set of test cases. And I know that several of those products from Peplink are T priority certified, and I think that's really what will be showcased here.
yep, absolutely.
I got one last question. I'm gonna send to you from the community here. It says, does millimeter wave support slicing, or only 5G sub-6?
Most of the millimeter wave deployments today are ENDC, which use 4G core, and so therefore they're not compatible with slicing, right?
Oh,
But
that goes into what you said earlier just a few seconds ago. Yeah.
yeah, so when millimeter wave gets upgraded to NRDC, that's where the concept of slicing, starts to come in. I think that's only done in small ways in labs in private networks. I don't think that's widely deployed in public macro networks for us or any of our competitors yet, but that will be on the roadmap, but it's not
Yeah,
available publicly yet.
that's really interesting, Jason, because on our side, we've avoided or just chosen not to deploy millimeter wave so far in our products because on the chipset side, on the UE, all of those are tied back to that first generation X55 chipset. And so it's a really, at this point, already a very old chipset. And so it was hard for us to really wrap our heads around putting that much effort into something that was so old. And it's interesting to hear that it also has the 4G ties on the network side. But regardless, we're looking forward to the new implementations there as well. And so we do expect to have some sort of millimeter wave product now that we're looking at it in a pure 5G SA context and these new X70 generation chipsets. So more to come on that too on the Peplink side.
Amazing. Sign me up for an early test unit. We have a few needs for those.
Cool. Yeah, absolutely. We talk more on that.
But Jason, I cannot thank you enough for jumping on and answering questions. I have been enlightened as well, and we work together a lot. And I learn every time you open your mouth, I learn something new, and I can't thank you enough for that. Um, and Yeah, I think, yeah, I'm just, thank you so much for coming and helping and sharing. And I know a lot of people ask really good questions, and I was trying to respect the request of commercialization and productization. So anything about SLAs or selling the service or how it's applied on the industry level, I thought I would ignore those questions out of respect for the ability to get Jason on here. But if you do have a T-Mobile rep or want to be connected to a T-Mobile rep where you can talk about those to someone that is selling the services, please feel free to reach out to me, peter@westnetworks.com, and I'll do my best to direct you to somebody in T-Mobile that can talk about that. But I try to avoid those questions in the Q&As. Otherwise, thank you so much. If you have any questions, you can email me or Travis at peplink.com, and we'll forward that off to the appropriate, people. So.
Yeah, thanks for having me, Peter. And
Excellent,
it's a great,
Jason.
great way to explain it, right? Yeah, talk to your T-Mobile for Business account rep about this, and yeah, maybe down the road we can do another session, maybe with T-Mobile for Business that can talk a little bit more about what they're offering when that time comes.
I would love it.
Absolutely.
Well, thank you very
Thank all
much,
of you
everybody,
for
and
showing up.
yeah, thank you everybody for hanging out with us for this hour. So thank you so much.